Thank you, sir.
Okay, no problem. Sandra, are you here yet? Are you here tonight? Marissa, do you want me to turn on my my transcript thingy? Okay, I will anyway. Okay. All right. So for the recording, the question was you're solving some problem, okay, and you do all the work and you get these answers: 5, 1/3, -2i, and 2 + 3i. Okay, the question was, how do I know which ones to use or not use? And my answer was, it depends totally on what the directions were. So if the direction said solve over the real numbers, then your only answer are the real answers. Those are numbers that are on a normal number line. If it says solve over the pure imaginary, then your answer is only those. Those are imaginary. That's actually complex. But if it said solve over the complex, then your answer is all of them, because the complex designation includes all the reals and all the imaginaries at the same time. The word complex number is all of these numbers. Everything we've ever learned is a complex number. Okay. But then Carmen kept asking, well, what happens if you did something like 5 + 2i times 5 - 2i? And you multiply these together, you get 25 minus 10i plus 10i minus 4i to the second. Does everybody follow what I'm doing? I'm distributing this mess together. Are you guys okay
Yes.
with my math? Okay.
Yeah.
What happens here? Two things happen. The terms in the middle drop out. Yay. I squared is worth -1. So this is -4 times -1. So this is +4. So this becomes 25 plus 4, and the middle chunk drops out. So the answer is 29. The difference is you're doing arithmetic. These up here, we were solving. Okay, so solving is governed by the directions. This is doing arithmetic. You just get what you get. That's the end of it. Is that okay or not?
Yes. Okay. Thank you.
Okay. Little aside for everybody. Mitch, do you remember that problem we did last night that Ann helped you on with the rate was really
Bacteria.
ugly?
Yeah.
Yeah. Do you have that? I'm going to get back to it in just a second.
1 second. I need to get through my notes.
Yeah. Okay. But for everybody else, tomorrow night, exam number 3 is on Canvas. It'll be open at 6 o'clock on Canvas. It's one of those show your work. So you download the problems, you do it on your own paper and upload it. And there is no multiple choice. It's just what you see on Canvas. That's the end of it. Okay. So you've got whatever those problems are, those are them. I somehow my multiple choice got lost. I don't know where it is. I can't find it. So to hell with it. Okay. So the only thing you're doing tomorrow night is this one test, and it's good enough. It's going to kick your butt. So be ready. Get some good sleep, start early, don't hesitate. But that's the only thing you're doing tomorrow night. Okay. I had a less than satisfying discussion with my department chair today. He really couldn't answer my questions about what's happening in the fall. I've been talking to you guys about, okay, should I go to 4 nights a week? Should I go to 3 nights a week? Should I put a lab, an on-campus one on Thursday or on campus on Monday? And I've gotten a lot of information back from everybody, and I pass that on. But here's a couple cool things. I don't know if everybody is aware of this. You might want to be aware, and you might want to start yelling and screaming. First, no food or drink in any of the buildings at any time that you're on campus. If you want to drink from your water bottle or anything else, you have to leave the classroom, leave the building, go stand outside. Okay, you can't go in the hallways, you can't go in the stairwells, you got to go out of the building. Okay. Second problem. Yeah, wow. Second problem, okay, is they're forcing us to come on campus, especially the people with X classes. Now, this is in math. Science is something different. Science wants everybody on campus all the time so they can do all their labs all the time. Okay. But for the X classes, like our class, or 104X, or 116X, all those X classes, they want the X students on campus one night a week, minimum. Okay. Here's the catch. Y'all won't fit into the same classroom. Not if we adhere to social distancing. So they're trying to see, they've already made this rule. You're going to come on to campus, damn it. But we may not have enough classrooms for you. They're working this out still. Okay, they don't know yet. Worse, if they can't find enough classrooms, then we would be having 1 week, half the class comes in for some personalized help, and the next week, the other half of the class comes in for some personalized help. So it'd be 2 weeks before you got any kind of individual help. In the meantime, that would cut into the time we have, like on the Zoom class tonight. We wouldn't have enough time to talk about what we're talking about, or to tell bad jokes, or even good jokes, or anything like that. Okay, it's just a big mess in the fall. Big mess. So, like I said, talking with the department chair, I was less than happy when I finished this afternoon at 4:30.
Are they going to require vaccinations?
Legally, they cannot. I forgot to ask that. Legally, they can't. Okay, until it's been approved by the CDC as a totally safe vaccine, then they will. But then they still have a problem. How do we know who's vaccinated? Do we check everybody's card? Okay. Do we check them as you come in? That kind of stuff. So what they're saying is, well, yeah, we're going to try and get everybody vaccinated when it's legal to do so. But in the meantime, everybody wears a mask. You cannot take it off. Okay. You've got a medical condition, too bad. Okay. Come back next semester.
That would be cool if they offered like half in person and half online. Like whoever felt unsafe to be on campus, they could do it on the same class that the people are in person. So
yeah,
like,
but
they
we
can
don't
get
have the tech. We don't have the technology to do that.
Yeah, or just like leave it
Yeah.
for online until it's like safer. It
Oh,
just seems so
that
crazy.
I agree with. That I agree with. I dislike online tremendously, but the option that they're giving us right now is ludicrous. Okay, I would love to go back in class in person. I'd love that. But this half and half crap, to me, is stupid. But whatever, they don't ask me. All right, Mitch, did you find that problem?
I have it pulled up, but I'm having troubles finding my breakdown of it. Did you want my answers? Is that what you're looking for?
Well, okay, I wanted to know kind of what it was. It was A of t, was it equals 40? E to the
so
RT?
yeah, the initial population at time t0 is 44.
44. Okay, that makes okay.
Yeah, and then Sorry, the whole thing is the doubling period was 20 minutes at time t equals 80 minutes.
Okay. 80?
Yeah.
All right, all right.
Oh, no,
So,
sorry, the doubling period of the bacteria population is 20 minutes. At time t equals 80 minutes, the bacterial population was 700.
wait, was this the same problem that we had to use the whole stinking decimal?
Is that the one that you're asking about?
That's the one I'm asking
Yeah,
about.
yeah. And then there was a range of answers.
Okay, well, somewhere in here, when we did this, we got the rate was the ln of 20 over 2,
Yeah, that's correct. Yeah.
right? Okay. Now, to let you know how much of a social life I don't know, I was really frustrated with this problem. I went to bed, woke up in the middle of the night, had a brainstorm. So I went to bed thinking about this stupid problem. Okay, whatever. So the next thing was, what was it? Was it 3 hours? Was that it? Or did it say something about 3 hours?
Yeah, it was. Find the size of the bacterial population after 3 hours, and it was 22,528.
Okay, so watch carefully. In 3 hours, A of 3 hours equals 44 times E to the ln of 20 over 2 times 180. Now, we kind of did this last night.
You missed the 0 in your 20.
20, thank you.
Larry,
No,
it should be
2 on top, 20 on bottom.
Yeah,
Is that right?
exactly.
Very good.
Yeah, okay, okay. So, and one of the things I left you guys with was, well, I guess you just use that whole ugly thing up here. But then this had me thinking, Ann and I were talking after class, and I was reminiscing fondly about my calculus in high school. And I started laughing at myself. We get so lazy with these calculators, and we just want to punch numbers in right away, that we forget to use our brains or our log laws in this case. So watch carefully. This is going to be 44 times e to the ln of 2 times 9. 20 and 180 cross cancel or reduce to make 9. Okay, so this is 44 times e. I'm going to move the 9 in front. You don't have to, but I want to make a point of this. This problem here and this problem here are the same thing. Okay, I just moved the 9 in front because remember, there's a log law. There's a log law that says we can move the 9 up as a power. So this is 44 times e to the ln of 2 to the 9th power. All right, now is where the magic comes in. We did a problem earlier tonight that used this formula, b raised to the log base b of box of something. B raised to the log base b of something becomes this something. These two canceled out. Okay. E raised to the ln of something is the something because the E and the ln are both base E. ln is implied to be base E, so E raised to the log base E cancels out and we get that. I can show you in more detail, but it's not that important. So what's going to happen here is this is going to become 44 times 2 to the 9th power. Okay. I got room. So let's see what my calculator says. 2 to the 9th power. Working in the dark is the pits. Come on, enter. Turn it on. Okay.
512.
512. Thank you. I'll trust it. So this is 44 times 512s. What's 44 times 512?
22,528.
Wasn't that the answer?
Yes.
Bingo. Okay. Now, what I told you to do and what Ann told you to do, and Ann saw this more than me, was use the whole decimal. But the difference is we went and got that decimal and we had this whole stupid decimal and we let the calculator do our work. But if I'd thought a minute, okay, and said, no, don't use your calculator, use your brain, then we could have used our knowledge of log laws to simplify this problem without using our calculator at all until we got down to here. And then we got automatically the exact answer. But again, I'm laughing at myself because once we had calculators, it's like part of our brain shut down and we just use the calculator all the time. And we could have done it this way. And the truth is when I first started teaching in high school, we didn't have, I mean, our calculators could barely add, subtract, multiply, and divide. So we were forced to learn all of these things. And then slowly, as we started using calculators, slowly we stopped utilizing some of these really cool tricks. But anyways, I just wanted to show you that that problem could have been done, okay, if I had had a brain. I didn't, so we all lose. Okay, I want to erase, I want to go into new stuff. And we might even get out of here fast or a short time tonight. So any questions on that? I mean, I like it, but yeah, you're not responsible for any of that. Don't worry about it.
Did you
Okay.
drink a margarita yet today?
No, I did not. I did not. Are you suggesting that?
Oh no. I just remember you said you like Cinco de Mayo.
No, I love them, but no.
It is Cinco de Mayo.
Yeah, it is. It's the Mexican holiday that the Anglos all usurped, and now we think it's wonderful. It's, you know, whatever. It's an excuse. Actually, if you've seen that, everybody in the world, but especially Americans, seem to think, oh, another holiday, let's drink. Oh, another holiday, let's drink. Okay, let's invent a holiday, let's drink. You know, that seems to be what we do. Okay.
The
I just
Germans
don't
over.
see. Oh, sorry.
Yeah. The Germans, well, they drink beer, but you know. Okay. Last night in 11.1, okay, we introduced the midpoint formula and the distance formula, which I'm not going to go over tonight. I'll go over next week. But we also introduced the circle. And the format for the circle was x minus h quantity squared plus y minus k quantity squared equals r squared. And the center was hk, and the radius was r. That number there, r. And for example, I tried to trick you. Okay, so what if I gave you, for example, x plus 3 quantity squared plus y minus 1 quantity squared equals 49. Okay, what's the center? Anybody, center?
Negative
Negative
3, 1.
three.
Negative 3. That's okay.
Go ahead, Carmen. You got
Comma 1. Is that all right with everybody? Negative 3, comma 1
Yes.
equals, and well, what's the radius?
7.
You guys agree? 7?
Yes.
Okay. So remember, the trick was we compare our problem against this formula. Think of this as a form or a formula that you need to know. Okay. And the formula says you have to have an x minus h and y minus k. You have to have that. If you don't, you have to think of this as minus a negative. That's how we got the -3 there. If you can do it in your head, great. Okay, but you do have to see that trick. All right. What I also said last night is what happened is this circle with radius 7 started at the origin at 0, 0, but got shifted. It got shifted to the left 3 and up 1. So normally a circle, okay, might be here. But this says, no, no, no. Take the center of your circle, shift it to the left 3 and up 1, and that's where your new circle is. That's what that's telling you. Okay, and then the radius was 7. So real quick, I want to spend a second, okay, on still on this problem. Okay. Can you find 4 points on this circle? Real quick, can you find 4 points that are on this circle? By 4 points, I mean 4 ordered pairs. You know, like is 7, 5 on the circle? Is 3, -1 on the circle? They're not. Well, I hope not, but they're not. But can you find the 4 points or 4 of the points? So I'll pause for a second while you think about that. Hint, sketch it. So I found one of them. Okay. Here, I'll find some other ones. This is what I was talking about if you didn't understand my discussion. This is the center, -3, 1. There it is. That's the center of my shape. Okay. And my radius was 7. So from the center, if I go up 7, I'm going to change my y value. My x value will stay the same, but my y value will increase by 7. So that's one of the points that I was talking about. Can anybody find another point?
If I wanted to do it just quicker in my head, can I just add or subtract 7 to both the x and y value individually?
That's all you're doing. That's all you're doing. But if we say sketch it, because remember, mom will expect you to actually use these points to help sketch it too. So as long as you can find it in your head, this will be 4, 1, because if you add 7 going sideways, -3 added 7 is 4. Okay. If you go back this way 7, -3 back up 7 is -10, 1. And come down here, wherever this is, -3, -6. Okay, this is this other point down here. So for you to draw your circle on mom, you're going to need the center, and you're going to need to find one of these points, because you're going to need to know how to use your mouse to stretch the circle out so it incorporates that point or that point, whichever shows up on your screen. So is that okay with everybody or not? Finding the center, using the center to put together a reasonable sketch of this graph. Okay, and if we had graph paper and could actually count 7, we'd have a really accurate one. So is that okay with everybody or not? I heard somebody say, yeah, but how about everybody? Are we okay?
Yes.
Yes.
Okay.
Yep.
Now, the last thing we did at the end of the evening was we talked about completing the square okay, to change an equation into what mom calls standard form. This is standard form. So what if some bozo comes up to you and says, hey, x squared plus y squared minus 12x plus 11 equals 0. What's the center? And what's the radius? Okay. Do you want me? I think I will pause for a couple minutes. Okay. Just a couple minutes to see if you guys can check your notes from last night. And we used CTS, complete the square, okay, to do that. So I'm going to pause for a second while you guys play with that. Okay. So the way we attack this is I got my x's together. So x squared minus 12x plus blank plus y squared equals negative 11. Now, I'll show you why I don't do anything with the y squared in a second. Okay. To complete the square, find your red pen. Okay. You take half of negative 12 and get negative 6, but then you square it. So negative 6 squared is 36. Okay. So you have to add 36 over here also. Remember, you have to add the same thing to both sides. So where did I get the negative 6? Half of the negative 12 is negative 6, but then you square it and add that amount to both sides. Okay. Again, I'm ignoring the y squared for a very important reason, which I'll show you in a moment. So this factors automatically, you don't even have to think, it's just going to become x minus 6 squared. Whatever you wrote there is what it will factor as. No thinking. When you write y squared, it already is a quantity squared. So you didn't have to use completing the square on it. It already was that quantity squared in there. And we did a problem like that a little bit last night, and I'm kind of showing you it again tonight. Over here equals 25. Negative 11 plus 36 is 25. Okay, so our center should be 6, 0. Our radius should be 5 because of the 25.
Can you repeat your reason for why y was 0?
Okay, because look at the form that we want. We want quantity squared. Did that just go blurry, or was that my glasses?
I
Oh,
think it's pretty dark
okay.
in your room.
Yeah, it is.
It went dark.
This is the same thing that we saw earlier. Sorry. Probably that'll cause my camera to go nuts. And I'm all screwed. Better? Sorry. Okay. Because look at the form. I want all of my x's inside a quantity squared. This is the process that gets all of my x's inside a quantity squared. I want all of my y's inside of a quantity squared. But they already are. All of the y's are being squared. Okay, so I just wrote it that way to emphasize that there's an invisible 0 with it.
Gotcha. Thank you.
Okay, and so that gives me the center is 6, 0, the radius 5, and I'm happy. And that pretty much brings us up to speed from last night.
Okay, sorry, just a stupid question. How did you get the 25?
Okay, do you understand where this 36 came from?
No, not really.
Okay, when you take half of negative 12, you get 6. But in the blank spot, you put negative 6 squared.
Oh, and then you have to times it by the other. That's right. Okay. Sorry.
You add it to the other side, because what you've just done is you've made this side of the problem, okay, 36 bigger. You've added 36 to this side of the equation. So to keep it balanced, you have to add 36 to this side of the equation. That's what I did.
Thank you. Sorry about that.
No, that's a good question.
Is the center -6 or +6?
Positive 6, because remember, when I have x minus h, I just take the h.
Oh, that's right. Okay, thank you.
Okay, no problems. I mean, this is all new. It's not hard, but there's enough new stuff here that it's easy to get lost. Okay, so basically I need to erase the board. Are we okay?
Yes.
All right, here goes. Now, that was a circle. We're going to jump to 11.3 because it's easier. I didn't want to do a whole lot tonight and boggle you. I wanted to be able to quit early tonight so you could either go home, get some good sleep, or stay and ask me questions or do whatever. Okay, so we're going to jump to 11.3 because it's a whole lot easier than 11.2 is.
Tacos and tequila.
Yes. Okay. That was another thing. I went to my wife and I a couple of years ago, several years ago, went to Spain, hiked across Spain. I was hoping, oh, good Spanish food. No. Okay. All they had was half-cooked fish and octopus. Okay. And I caught some kind of stomach disease. So I'm hiking 500 something miles across Spain with, oh, my stomach. And all they have is fish soup, and octopus. And I'm just going, oh, please, God. Okay. Save
Is
me.
the octopus still alive? Maybe that was the problem.
No, it wasn't alive, but it sure looked gross and it tasted blech. Okay.
Drink the
Was the
sangria.
problem hiking back?
Pardon me?
Was the problem when you were hiking back?
No, we went from we actually went from Pamplona over to what's it called? Santiago de Compostela. We walked there, then we took a train down to Barcelona or over back to Barcelona, and then we flew home. So we didn't walk back. We walked all the way across northern Spain, the Camino de Santiago. Okay, but it's really cool. Someday I'll talk about it. But it wasn't food that I really, really wanted. It was pretty icky. And then when you ate something that was not good, you got some bug in you for like weeks and weeks. I lost a whole lot of weight. It was good. Okay. Anyway, back to here. Compostela de Santiago, Camino de Santiago. Really good if you guys can do it. Okay, we're going to talk about something called an ellipse. Now, most of you kind of know what an ellipse looks like. You'd call it an oval. Okay, that's an ellipse. But think about this. If you think of a circle, okay, and you squeeze it this way, what happens? Well, it turns into something flat like this, but something else happens. This center, okay, think of it as you guys know what happens when you take an atom and you put it in a cyclotron or something like that, and they bombard it with all these other beams of exotic chemicals, your atom explodes into other smaller pieces. Well, think about by pushing pressure here, the center explodes into something called a focus out here and here. Okay, you have a focal point, or these are called foci. foci, or focal point. Okay, so a circle just has a center. But when you warp it by squeezing it one way or squeezing it the other way, the center bursts open, okay? And you still have the center, but it also creates something called focal points. And next Tuesday, I'll talk to you more about that, okay? But it's important that you know that, okay? The center gets split into two focal points, okay? If you have a chance over the weekend, okay, look up how to draw an ellipse. It's really kind of fun. Okay, you take a push pin and a piece of cardboard. You put a push pin there. You put a push pin there. You take a string, okay, and tie it here, but then you take your pencil and pull it tight. So instead of a loopy string, you pull it tight. And then you start moving your pencil around, okay, keeping this string tight. And you'll see that eventually you create an ellipse. And these two pins that you put down are called the focal points. And midway in between them, midpoint, get that, is the center. So the center is the midpoint between the two focal points, which is why we needed that. Okay, and next week I'll talk about how the distance formula applies to this. But what you need to get out of this right now is that a circle, okay, when you squish it one direction or the other, the center bursts apart. We have a center, but it also creates two that are called focal points. A little bit more vocabulary, okay? There's a long axis and there's a short axis. When you depending on which way you squish it, if you squish it this way, then your long axis is this way and your short axis is this way. That just depends on how you squish it. Okay. The long axis is called the major axis. The long one, whichever way it is long, that's the major axis. And your short one is called the minor axis. Okay. I'm not real big on this, but Mom is. Okay. This is called, the end points here are called the end points. When it talks about the end points, it's always the end points of the major axis. Okay. And I think, and I totally forgot I'm having a brain whatever on this. These are called the excuse me, they're not endpoints, stupid. They're vertices, vertices, plural of vertex. I beg your pardon. I was totally spacing on this. So when it talks about the vertices, it's always the endpoints of the major axis. That's plural, that's singular. The endpoints of the minor axis are called the co-vertices. So when you're reading Mom, okay, just for your understanding as you're doing the problem, the word major axis, okay, refers to the longer axis, the longer one. And that depends totally on how it's been squished. So major axis isn't always horizontal or it isn't always vertical. It just depends on how you squished it. The minor axis is the short one. Okay. The vertices or the vertex is always of the end points of the major axis. And the co-vertices or a co-vertex is the endpoints of the minor axis. And that's about all the vocabulary you need. Okay, I'm done with that. So All right. I need to erase this in a second, but you need to understand that an ellipse is incredibly related to a circle. Because think about how I described creating an ellipse. You start with a circle and you squish it, and out pops the focal points and all this other stuff. So an ellipse is related to a circle. Can I erase this crazy drawing?
Yes.
It's not critical. Maybe the vocabulary is a little bit, but this drawing is not yet. Okay. So here comes the formula that you do need to know for an ellipse. X minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. X minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. So there are some similarities to a circle. A circle was x minus h squared plus y minus k squared equals r squared. So this hk, which was the center of a circle, is also going to be the center of our ellipse. But a circle equaled r squared, my ellipse will always equal 1. An ellipse has these extra things down here that I need to talk about. And they're not hard. I believe I'm the only person in the world who uses the following vocabulary. Maybe I'm not. I think I am. First off, the center of our ellipse is the same as the circle. It's HK. And you have to use the same tricks. Okay, you take the opposite if you need to. Then I introduce something called the X radius. And that's plus or minus A. Notice it's the X radius because it's under the X value. And it's A, not A squared, but A. The Y radius is plus or minus B. Okay. Now, keep in mind, a circle has only one radius. Anywhere you measure a circle, it's always the same. That's why we could go on that problem I had up here. I'd go up 7, down 7, to the right 7, left 7. It didn't matter. 7 was the radius, and we always went from the center. But not quite in an ellipse. Let's take x plus 2 squared over 5 squared plus y minus 1 squared over 6 squared, not 6, let's say 9 squared equals 1. So take a second, write that down. X plus 2 quantity squared over 5 squared plus y minus 1 quantity squared over 9 squared equals 1. Okay. The center is -2, 1. Is that all right with everybody? You understand why it said +2, but I write -2?
Yes.
Okay, it's the same logic that we, huh?
I don't understand why you're switching it, the
Okay.
signs.
Because check it out. The formula for an
Oh,
ellipse
okay.
has that minus, so we have to cheat it as minus a negative. And that's how we got the -2. We have to make either on your own paper or at least mentally, you have to make the problem match the formula.
Okay, got it.
Okay, okay.
Yeah, thank you.
The x radius is plus or minus 5. The y radius is plus or minus 9. Just those numbers there. Okay, here comes the sketch of this sucker. Okay, start at -2, 1, -2, 1. Boom. All right, now think about those crummy drawings I had here a few minutes ago. Okay, I'm just going to show you. This got squished in some way. So the x radius is 5. Okay, in the x direction, we're going to go 5. So if I said -2 plus 5, this is going to be 3, 1. How come? Because I added 5 to it because that was the x radius. But wait, okay, I can also take away 5. Okay, this way. And that's going to be, okay, my scale is really screwed up now. So if I subtract 5, what's this point?
-7.
-7, 1. You guys agree? So my x radius changes the x values. Now my y radius is going to change my y values. My y radius was 9. So from the center, I'm going to go up 9. So if this is 5, okay, sort of like right there, I went up 9. Where is there? If I'm at -2, 1, and I go up 9,
-2, 10.
you guys agree?
Yes.
Ouch. -2, 10. Okay. And just roughly, fingers, if I go down 9, where am I?
-8.
Negative.
-2, -8. You guys agree? 1, take away 9 is -8.
Yes.
So here's my ellipse. Okay. Sheet looks better. Sheet looks better. That's it. Mom is going to have on her screen, she's going to have pictures of, oh, is this a line? Is this a circle? Okay. Is this an ellipse? It'll do something like that. It might be a parabola. Okay. It might be a hyperbola, which we still have to talk about. So mom is going to have a menu. Okay. You're going to have to select the ellipse choice. Click on the center, that'll center the ellipse. And then it's a little bit tricky, but you're going to have to move it, open it up sideways to go through one of these points, and then open it up vertically to go through one of these points. Okay, and once you figure it out on mom, it's a pain right at the very beginning, but it's just not that bad. So you click whatever shape it is, you go center, and then you play with your mouse to kind of, okay, spread it wide so it goes through one of these points. So you need to be able to calculate these X points. You have to be able to calculate the X points. And then you kind of spread it out the other way and calculate the Y points. Okay, and pretty much that's a graph. That's it. That's all there is to graphing an ellipse. And I'm going to do one more graph that's a little trickier, but this is it. So questions?
Other than because it's math, why does it equal 0?
Equal 0 or equal 1?
Oh, 1.
Okay. If it didn't equal 1, then you wouldn't know what your X radius and your Y radius was. Okay. If you multiplied by the LCD, hold on. Okay. If somebody wrote X plus 2 squared plus Y minus 1 squared equals 2025. That problem right there, X plus 2 quantity squared plus Y minus 1 quantity squared equals 2025. That's the same problem, okay, as this one, except you have no idea what the X radius and Y radius is. By forcing it into this format, it tells you what the X and Y radius is. Okay, so the 1 is kind of critical to us because it'll force these numbers to appear and those help us to graph it. Now, I'm not sure that was the answer you're looking for.
I can understand. So
Okay.
the equation will always be like this, like we won't have to figure it out.
Oh yeah, you'll have to figure it out. That's what I'm going to do in a few minutes. Like, remember, like on a circle, we use completing the square.
Yes.
Yeah, we're going to do the same thing in a few minutes on an ellipse. It's a little bit harder, same idea. Okay. All right.
Excuse me, can you explain about center? Why we have -2 and 1?
Okay. Because, okay. Okay, so here's the original problem, right? X plus 2.
Mhm.
But the formula for an ellipse says it has to be X minus.
Okay.
The formula says it must be X minus. So you have to take this problem and use your math knowledge. Instead of saying X plus 2, you know that that's the same as X minus a -2, because we know that minus minus is still plus.
Okay. Yeah.
So now, because it's a minus, it matches our formula, but now we know our H number is a -2. Yes or no?
Yes. What about
Okay.
1? Why is positive?
Because it already is a minus. See, the formula says it's got to be Y minus K. And then we use the K. That's what it says. When it's Y minus K, we just use the K value. This is already Y minus, so I'm okay. I didn't have to do the same trick.
Oh, okay.
Okay or not okay?
Yeah. Right now it's okay. Thank you.
Okay, right now. A few more minutes, you'll be lost. Okay. All right. All right. Let's try another problem. Okay. So new problem, X minus 1 squared over 16 plus Y plus 3 quantity squared over 100 equals 1. Okay. I want you to find the center, the X radius, the Y radius, and sketch the graph just like I did up there. The co-vertices, ordered pairs, the vertices ordered pairs. So we'll pause while you guys work on that. Okay, without turning on the recorder, I put this up. The center was 1, -3. That was our H. Remember, we have to use the trick when it says plus sign in there. So we have to change it to minus minus. So 1, -3 is the center. The X radius was plus or minus 4. The Y radius is 10, plus or minus 10. So any questions about these values before I actually start the graph of this thing? Any questions where my center came from, how I got the X radius, how I got the Y radius?
How you got your X radius?
Okay, because the X radius is under the X. You see 16, but you have to write it as 4 to the second power. The X radius is this number, A, right there. So you have to write it as somebody squared. So 4 to the second power is 16, okay? And the same thing happens with 100. You have to write it as 10 squared because the formula that we're using says it has to be somebody squared underneath the Y value.
Okay, thank you.
Okay, anybody else? Okay, then here we go. This won't be to scale, but oh well. So we go 1, -3, right about there. Oh, it's not going to be to scale at all. My X radius is 4. So if I go over 4, so this would be 5, -3. So if I go over 4, and then if I come back 4, this would be -3, -3. So I'll put this on, then I'm going to erase it. So if I use my X values, if I go -4 or +4 from the center, always from the center, I got that point, 5, -3, and I got that point, -3, -3. Yes or no? Sandra, I didn't see you there. Boom, come on. Turn off. Okay. Yes or no? Is that okay? Do you guys understand how I use the X radius to get the endpoints in the X direction, left and right? Yes, no?
Yes.
All right. Then I want to get the endpoints for the Y direction, but the Y is going up 10. Okay, so going up and down changes the Y value. So I'm guessing roughly this would be 1, 7, because -3 up 10, -3 plus 10 is 7, and come down that far, roughly, this would be 1, -13. Because we went down 10. Again, you don't have to go this +4, -4, +10, -10. You just have to know how to do the math in your head and get these points, because that's how you're going to be able to graph it on MOM. Okay, it's going to ask you for the center and then spread it out until it goes through one of these points sideways, and then stretch it out until it goes through these points. Okay, connect the dots. Try and make an ellipse. Okay, remember it's smooth curve, it's not pointy, but that's it.
Can I mention something about that and Mom?
Sure.
So I was playing around with it while you were talking instead of paying attention, of course. But
Yeah, sure. Okay.
so on
Go ahead.
Mom, I would put the center and then move the mouse over and then up, and then that's when I would click the second dot. So the spot that it is clicked is on the outside of the ellipses for anyone who wants to work on that later today.
So what do you mean? So when you move it over and then you move it up so that it stretches to here, and that's the point you click on?
Yes.
Is that what you're saying? Yeah.
Yes. So you
okay.
click on it twice.
Yeah.
That's it.
Okay. I mean, you figure it out. It's, at first it looks scary and then you go, well, duh, I get it now. It's easy. But is that okay with everybody or not?
Yes.
Okay, now I need to erase this and do one more thing, but I want to talk to somebody. I think a couple of you asked, and Vince asked, does it have to equal 1? Okay, and I said, yeah, it does, because otherwise you won't have these numbers here. If it didn't equal 1, if it equaled something else, you wouldn't be able to tell the x radius and y radius. Later on in pre-calculus, you're going to revisit these again, okay? And they're going to have you measuring, using a formula, something called the eccentricity. Now, you've heard of weird people, being eccentric. They're being kind of weird, crazy, outside of normal, okay? Well, by knowing these two values, there's a formula that puts them together that tells you how stretched is this? How much out of circle? Remember, a circle is our perfect shape. So how much out of round is this? And by knowing this, you can set up with a ratio, 10/4, and that helps you calculate what's called its eccentricity. How out of shape it is, how eccentric is it? And if it didn't equal 1, you couldn't make that calculation. But that's in a couple of semesters, so don't lose too much sleep. All right, I need to erase the board, pretty much. Are we okay? Can I erase it and introduce one last topic for the night? Okay. I'm only going to do one problem of this. And then when we come back next Tuesday, I'll do some more in practice. Okay. Some of you will be able to figure it out. It's not that bad. It just looks scary. So let's say we had this problem. Okay. And I have 2x squared plus 9y squared minus 8x plus 18y minus 1 equals 0. Okay. For what it's worth, you can tell it's an ellipse because the coefficients of the x squared and the y squared are different. If you go back and look at the notes, do you remember when I had x squared plus y squared minus 6x plus 12y minus 11 equals 0? Remember, whatever that problem was when we did completing the square on a circle? Okay. On a circle, the coefficients are the same. The coefficient of the x squared and the y squared are the same. In this case, they happen to be 1. On an ellipse, the coefficients of the x squared and y squared are different. So you can glance at this and say, they're different, it's an ellipse. They're the same. The coefficients are the same. It's a circle. It's that easy. I can tell that's an ellipse. I can tell that's a circle simply by looking at the coefficients of the squared terms. Okay.
Would you be able to tell by the 1 also, or do they not always have the 1 right there?
No, that could be 7. That could be 9. It's hopefully the one is there. I haven't checked my notes to make the problem work out pretty. All right, so we're going to start the same way. We're going to start with lumping our x's together. 2x squared minus 8x plus blank plus 9y squared plus 18y plus blank equals 1. Move the 1 to the other side. That's exactly the same thing we did for a circle. We kind of got our x's with our x's, our y's with our y's, move the number, the constant, just out of the way, move it over there, and leave room for the magic number.
It will always be plus blank, correct?
Yes. Because remember, what you're going to do is you're going to have something and then square it. So by the time you square it, it's going to be a positive number.
Gotcha.
Okay. Okay. Now, get this super, super important. Super important. This is why I didn't push it back in chapter 9. You can't complete the square, cannot complete the square if the coefficient is more than 1. Okay. If you go back and look at all of the problems I did, the coefficient of the x squared was always a 1, or the coefficient of the y squared is always a 1. That's one of the problems with completing the square. It's very limited in its usefulness. So how do we get around that? Okay, we factor. Take out a 2. X squared minus 4x plus blank. Okay, plus factor out a 9. 9 quantity y squared plus 2y plus blank equals 1. Okay, somehow in your notes, I don't know how, but you can't complete the square if the coefficient isn't a 1. It's got to be a 1 x squared. The way we get around it is by factoring out that coefficient out of all of the x's. And we factored out the 9 out of all of the y's. So now for us, this is a 1x squared and a 1y squared, and I'm happy I can now complete the square. Okay, so take a second, get that in your notes, okay? You can't using completing the square when the coefficient isn't a 1. It's got to be a 1. How do we get around it? Factor a 2 out of all the x's, factor a 9 out of all the y's. All right, here comes now trick number 2. Okay, how do I complete the square? We take half times -4 is -2, but we square it and go -2 squared. That's exactly what we did when we did the circle. Half times -4 was -2, but when we put it up here, we write it as -2 squared. So 4. Hang on a minute. Over here, I'm going to add 8. I know it's hard to see, but I just added, I'll add 8 here. Okay, now wait a minute. How? Wait. I added 4. -2 squared is 4. But over here, I wrote +8. How? Why?
Is that because of the 2 you factored out?
Good. Because inside the parenthesis, that is 4. But it's being multiplied by this 2. So what have I actually added to the problem? 2 times 4. I've added 8 to the one side, so I have to add 8 to the other side. Think about that. I added 4 inside the parentheses, thinking small, but in context of the whole problem, I've actually added 2 times 4, thinking bigger. So I've added 8. So I have to add 8 to the other side to keep it balanced. Now, how about my y's? Half times 2, does the blue show up? Or should I go to red?
I can see it.
Okay, is 1. So I put a 1 squared there, because that's what we always do. So I put a 1 squared. But what do I add to the other side?
9.
9. Because inside, thinking small, I added 1. But thinking of the bigger problem, I added 9 times 1. So I have to add 9 to the other side to keep everybody happy. All right, so hold on, here we go. Okay, so this becomes 2 times x minus 2 squared plus 9 times y plus 1 squared equals 18. Excuse me.
That's
Okay.
a x minus 2?
Yeah.
Okay.
Bad handwriting. Okay. But this is an ellipse. This is an ellipse. First off, I've erased it, but an ellipse has to equal 1. It equals 18. An ellipse is supposed to equal 1. Further, look at this ellipse formula. Does it have something times x minus h? Is there a multiplier out here? No. So I got to get rid of the 2. I can't have that 2 there. That doesn't show up in the formula. There's not a multiplier. There's not a multiplier times the y. I got to get rid of the 9. So I got to make this 1, and I got to get rid of the 9 and the 2. How?
Division.
Hmm?
Can you divide it?
Yeah, divide everybody by 18. So this is x minus 2 over 9 plus y plus 1 over 2, y plus 1 squared, I'm sorry, over 2 equals 1. And now it's in form ready for us to graph. Now you can tell me, we already had predetermined it was an ellipse because the 2 and the 9 were different coefficients. But you can say, the center is 2, comma, negative 1. Okay, you can look at it and see the center is 2, comma, negative 1. You can tell me the x radius is 9. Y radius is a little bit weird. Okay, but I've gone through the major stuff. I'll show you the y radius in a moment. So let's stop and ask questions. It's go ahead.
Is it just coincidence that the 2 and the 9 came down and swapped? Is that just with this problem?
It was just, yes, it was. Because if I'd made this, what if this for some reason had equaled 36? And I divided everybody by 36, this would be 4. 9 divided by 36 is 4. 2 divided by 36 is 18. So they would have been totally different. So it's just a coincidence. It's just what happened to work out.
So is the y points going to be radical too?
Yep. Okay, good call. So how do you take 2 and write it as a square? 2 is the square root of 2 squared. Okay, that's kind of tricky. That's hard to see. Okay, you shouldn't have too many of those on mom. And if I'm any good at writing the test, you shouldn't have any of those. Okay, but you're right. So that's your y radius right there. So you take 2, like if you had 7, well, 7 is the square root of 7 squared. You can do that with any number you want. So you can take ugly numbers and still write them as square powers. Okay, and with that, I am done for the evening. 8:09. I think that's a new record. Well, it's new because the computer didn't crash. I think we quit one night early because I kept having computer troubles. So I'm going to pause this. If you want to quit,